Alright, so here let's look at some examples of how we can apply our understanding of linear regression. So here's our example here. So let's say consider the given data in the following table. So our data is being recorded as a pair. So there's a column for X and there's a column for Y. So now looking at this data right here, the first question being brought up now is that we want to find the equation of the best fit line. And so before we can proceed into the equation of the best fit line, we need to enter this data into some kind of technology. So I use the TI calculator, but you're not limited to this calculator. You can use Microsoft Excel, or you can use any other spreadsheet program that runs just fine on handling this kind of data. So now here's how I enter my data into the two lists here. List L2 has my X list, and list L3 in my calculator has my Y list. And so back to the question, find the equation of the best fit line. And so the technology can once again handle that equation for us here. So once again, I'm going to come back to my calculator and show the equation. Alright, so my equation here now in 4 decimals, this as a clarification, this is my slope of the best fit line, this is my y-intercept, and optionally this is my correlation coefficient for this data. And so now concluding our question, and that's how easy we can find the equation of the best fit line in this example. And so our equation of the best fit line is simply y hat equals minus 0.0034, and to keep things simple, I'm going to use only 4 decimal places. X hat plus 1.082, actually rounded to 4, and it's 0.083, and that's about the best we can do. So there is our equation for the best fit line. And this is the answer to part A. And now the same data here, the next question being brought up here is that let's predict the value of y variable when x equals 70. So remember from the lecture that the entire purpose of coming up with the best fit line equation is to predict value. So here in this question B of the current example, we are going to predict the value of y. And notice that x, the given value for x equals 70 right here, is actually not given in the data. And that's actually the point right there, because we're attempting to use the equation of the best fit line to make prediction to those values that are not part of the table. And so here's how we can go ahead and proceed. So the plan here is that our equation already found y hat equals negative 0.0034 times x hat plus 1.083. So if carrying out the calculation by hand, then we just simply substituting. Remember that x equals 70. And so calculating this once again by hand is simply as just substituting the value x equals 70 into your best fit line equation. So minus 0.0034 multiplied with x hat being substituted by 70 plus 1.083. Another option is that we can use the calculator, or once again use any kind of technology, but here in this demonstration, in this example, I am going to continue staying using my TI-84 calculator. So on my home screen, I am going to hit the y equals button. And so here's a few empty functions being prepared for me to enter in, I am going to use my y1 to enter my function. So my best fit line equation now is going to be negative 0.0034 times the x variable, I'll just use that variable key right here, plus y-intercept is 1.083. I am now going to enter that equation into the y1 slot right here, and now after getting that I am going to hit on table. So second table, that brings up my table here, and all we do now to find out the final value in the x column right here, all we have to do now is to search all the way down to, or we can continue searching. Alright, so now when we search to x equals 70, then the corresponding value would be 0.845, and that would be exactly the same value if we were doing it by hand. So here our predicted value for y would be y hat equals 0.845. That's how we answer a question in part B. And question C of the example is pretty much the same with question B earlier. So what it asks here is to ask us to predict the value of y when x equals 100. And so once again, we're still working with the exact same set of data, so I am expecting to use the exact same best fit line equation. So here it is again, my best fit line equation, y hat equals negative 0.0034 x hat plus 1.083. But this time we are given at the x value being 100. And so with papers and pencil, what we do is simply using the equation negative 0.0034 and substitute in the value 100 for x hat. Then we plot 1.083. And value will come out at the same time back to the TI-84 calculator. Then we can continue scrolling down until x equals, and in the x column by the way, so keep scrolling down until x equals 100. And so the corresponding entry to the right hand side, y1 here, the y value has to be 0.743. And so if we were doing it by hand, the calculation would come out the same, 0.743. And then here in this example, I'm leaving rounding out of the problem because it will depend on every different problem that everyone is doing out there. The last question being brought up here in the same data, regarding the same data, is that let's predict the value of x when y equals 0.9. Now, admittedly, this kind of question doesn't happen too much in our work. However, it's special enough to put in some consideration. And so, once again, back to my best fit line equation. This time we have the y value given being 0.9, but we need to find out what is the corresponding, or what is the predicted x value that happens when y equals 0.9. And once again, notice the value 0.9 is nowhere located in the table here. And that's the whole point of using the best fit line equation. We would like to only predict, we only want to predict the value of the other variable. And so, taking this class, everybody should be familiar somehow with solving a basic linear equation. But 0.9 now is going to substitute for y hat. So 0.9 is substituting in for y hat on the left hand side equals negative 0.0034 x hat plus 1.083. And so now at this point we simply just solve this equation for our x hat variable. And so now I'm gonna, the standard step here for solving equation, linear equation, subtracting 1.083 from both sides of the equation. And that comes out left hand side giving me negative 0.183, and the right hand side has negative 0.0034 x hat that remains. Then the next step is to divide both sides by that negative 0.0034. Negative 0.0034 is to be divided on both sides. And so final answer comes out, and allow me to switch the equation around. And so now I prefer to write my x hat value on the left hand side. It's just about comfortability here. But x hat now turns out after calculation being 53.82. And so once again, I'm leaving rounding out of the problem here of the example, since every problem that everyone is doing out there will have different rounding requirements. And that's all we have for this example.